In this problem, we're asked to find the equation of the graph for a sine function. And so the first thing that I'm going to do is I'm going to try to identify the center of the graph, and so the sinusoidal axis. And so right away I can see that my highest point occurs when y is 4, and then my lowest point, my minimum, is when y is -2. So I'm going to take 4 plus -2 and divide that by 2 to get the location of the sinusoidal axis. So it will give me 1. So I'm going to go ahead and draw in a line at y equals 1. So now that I can see that that's the center of my graph, this will help me identify any vertical translations as well as the amplitude. And so the amplitude is always the distance between that sinusoidal axis and a maximum or minimum point. And so you can see the distance from 1 to 4 will be 3. So I know that my amplitude is 3. The other thing to keep in mind is that normally the center of the graph, if you look at the graph of sine and cosine, normally the sinusoidal axis is the x-axis. And so normally it occurs when y is 0. Looking at ours, our sinusoidal axis is now 1 unit up, and so that tells me that I have a vertical translation up 1. So next I'm going to try to find my horizontal transformations. And so I know that sine normally crosses at the origin where it has an inflection point, and then it starts to increase afterwards. And so looking at my transformed graph, that would correspond to this point right here, where it crosses the sinusoidal axis, it's an inflection point, and it starts to increase. So if I follow this point, I can see that it was shifted to the right 30 degrees. So that is my horizontal translation, which is right 30 degrees. The last thing that I need to look at is how the size changed horizontally. And so if I follow this point, it increases, decreases, hits the sinusoidal axis again, continues to go below that sinusoidal axis, and it's at this point that it will start to repeat. And so I can see that I have one full cycle right here. And so I can see that this cycle size goes from 30 to 180, so I know that the period is going to be 150 degrees. Now, for my equation, I need to figure out the factor in which we're changing it by. So I'm going to take what my period currently is, which is 150 degrees, and divide that by 360. We then can reduce this to 5 over 12. And so remember, when we go to put this into the equation, this is the factor, but we're actually going to write the opposite. And so now that we're ready to write our equation, my amplitude is 3. That's a vertical size dilation, so I'm going to multiply that by my sine function. Next, for the inside, I'm going to change it horizontally by a factor of 5/12, since it's now smaller. So in the equation, I'm going to do the exact opposite and write that as 12 over 5. You will want to make sure that you have parentheses now for the inside of the function. And since we're in degrees, I'm going to use theta. Our horizontal translation was right 30. Again, we think opposite, so we subtract 30 and use that degree symbol. And the last thing is we are shifting the whole entire function 1, so we add 1 to the entire function, and we're done.